Today I'm going to answer a very simple but very important question. How do we know that our measurements agree with expected values? Let's say you did an experiment and you measured your acceleration due to gravity, and let's say your experimental value came out to be 9.6 plus minus 0.1 meters per second squared. And we know that theoretical value is 9.81 meters per second squared. So do these values agree? You might say that they kind of do, and I will agree with you, but unfortunately we're doing physics and kind of agree cannot be an answer. And we need to find a reason why these values agree or don't agree. So a very simple way to find out the reason is to draw a number line. So let's draw a number line. So here are all the values around our experimental values and expected theoretical values. So let's label them on the number line. So the theoretical value is 9.81 meters per second squared, and it's going to be somewhere here. And our experimental value is 9.6. And it has an uncertainty of plus minus 0.1. And we're going to label, so minus 0.1 is going to be here, and plus 0.1 is going to be here. So our experimental values fall somewhere in this region with an uncertainty. And you can see that the theoretical value actually does not fall in the range of our uncertainty. So our experimental value does not agree with our theoretical value, although, like we said before, they kind of agree, so they're same order of magnitude, and in your report you will have to explain why your value disagrees with the theoretical expectation. So now let's say you did two different measurements using different methods. So let's say you measured some velocity using the first method, and it came out to be 5.6 plus minus 0.2 meters per second. And you had the second measurement of velocity, and it was 5.8 plus minus 0.1 meters per second. So how do we show if these measurements agree with each other or not? Let's draw a number line again. And now we can find our experimental values on this number line. So the measurement number 1 is 5.6 plus minus 0.2. So minus 0.2 is going to be 5.4. And plus 0.2 is 5.8. So it's this region. And the second value is 5.8 plus 0.1 is going to be at 5.9, and minus 0.1 is going to be at 5.7. And you can see that we actually have an overlap in these two regions between 5.7 and 5.8, and that means that our measurements agree within the uncertainty. And that's how you know if your measurements agree with prediction.